Now here OA is the crank which is rotating uniformly in the anti-clockwise direction. So velocity of A with respect to O is perpendicular to this particular crank and in the anti-clockwise direction. So this vector velocity of A with respect to O, that is VAO, is as shown over here. These are all the oscillating links. So OA is rotating, this ACB link is oscillating, then CD is oscillating, BE is also oscillating, and E is the slider which is sliding with respect to the fixed point. So C with respect to A is also perpendicular to this particular link. Then C with respect to D, that velocity, it is also perpendicular to this link at any particular instant. Similarly, velocity of either E with respect to B or B with respect to A is always perpendicular to this particular link. Now here we have taken A with respect to O because O is the fixed point, but in case of AC, neither A is fixed nor C is fixed. So we can say that either velocity of C with respect to A or A with respect to C, and it will be perpendicular to that particular link. Then C with respect to D because D is the fixed point. Neither B is fixed nor E is fixed. So velocity of, we can say either E with respect to B or B with respect to A, that is also perpendicular to this. And velocity of E is sliding in the horizontal line, correct? So that path is horizontal. So velocity of E with respect to fixed point, that is either O or D, and it is sliding in this particular horizontal path. So it is shown over here along this particular horizontal line. So these are the various velocity vectors. But out of this, all these particular vectors, velocity of A with respect to O is known in magnitude as well as in direction. Whereas we have to find out what is the velocity of this particular slider. So here, first we'll find out what is the velocity of crank OA. As per the dimensions which are given, the length of this crank is 0.15 meter and N, that is the rotational speed, is 150 rpm. So we'll get the velocity of A with respect to O as 2.36 meter per second. Now this vector we are representing by, so this is the first vector. So on this space diagram, first mark O, which is the fixed point of the mechanism. So you can say O and D, both you can mark over here. Here only O is shown. So O and D you can mark in this particular case. Then draw a vector parallel to this particular vector. And suppose we have taken the length of 3.79. You can take any length. You can take 4 centimeter, you can take 5 centimeter or 6 centimeter. So suppose 3.79. So in other words, this velocity, actual velocity is 2.36 meter per second, and that is represented by a length of 3.79 centimeter. So 2.36 meter per second represents 3.79 centimeter. Then 1 centimeter represents how much? So it is, the scale is 2.36 divided by 3.79. So on our space diagram, 1 centimeter represents 0.62 meter per second. So this is the velocity scale. Now if we try to understand how to draw this particular rest of the vectors and how to determine the rest of the vectors, or you can say velocity diagram, then first step we have done is velocity of A with respect to O, that is this particular vector we have drawn over here as shown over here. Then so this is O and A, we are finding out the velocity of A, so arrow is towards A. So this is the vector velocity of A with respect to O. Now we'll come to the second vector, that is velocity of C with respect to A. Out of this C and A point is known. So from A, draw a line parallel to this line. So that is drawn over here. Then third vector is C with respect to D. Out of this C and D is the fixed point, that is nothing but O. So from O, draw a line parallel to this vector, so that we have drawn over here. So these two lines, right, they will intersect each other at point C. So we'll get the point C over here. Now point B on the velocity diagram can be found out by the ratio and proportion. So we have taken the ratio and proportion over here like this, that is AC upon CB is equal to AC upon CB. So this AC upon CB on the space diagram is equal to AC divided by CB on the vector diagram. So out of this, AC is known, CB is also known to us. Only unknown is CB. So CB, this small CB, that is CB is equal to, you can say that it is CB divided by AC into AC. So measure this particular length. By scale, this CB is 1 centimeter, this AC is 4.5 centimeter, and this AC from the velocity diagram, this AC is 0.85 centimeter. So you'll get CB is equal to 0.19. So from C, extend this AC further so that you will get this CB is equal to 0.19 centimeter. So this is shown over here. So in this way, we can find out this particular B point. Once we get this B point, now the next vector is E with respect to B. So out of this E and B, B point is known. So from B, draw a line parallel to this particular line, so that we have drawn over here. Then E with respect to O, that is the velocity of the slider in a horizontal path with respect to fixed point O, is along the horizontal line. And out of this E and O point is known. So from O, draw a line parallel to this line. So this line and this particular line, they will intersect each other at point E, because the common point between these two vectors, that is EV and EO, is E. So point of intersection is also E. And now we have to find out the velocity of slider. So this is the vector. We are finding out velocity of E. So arrow must be towards E. So E with respect to O. So in this way, we can draw this particular velocity diagram. Now we have to find out the velocity of this slider VEO. So for that, we have already calculated scale. So just measure this length OE. So length OE centimeter and multiply by the scale. So measure this length and multiply by scale, you will get the value equal to 1.05 meter per second. So at this particular instant, when angle is 210 degree from the positive x-axis, the crank is making an angle of 210 degree from the positive x-axis. The value of velocity of the slider is 1.05 meter per second, or approximately 1 meter per second. So this is the mechanism for which we can draw the velocity diagram as shown over here. Now in this particular case, we'll draw, or rather we'll see the velocity diagram for each and every degree of the crank rotation. So here the program is made in such a way that you can find out the velocity of this slider for each and every rotation of this crank. So here you can see, as the crank rotates, the nature of this velocity diagram will also change. And not only that, we'll get the value of velocity of E with respect to O. So that is also changing for the various position. For example, if you want to find out what is the velocity when the crank is at 222 degree, then it is 0.68 meter per second. And the nature of diagram is like this. If you just change this particular angle, then suppose the angle is 228, the velocity is 0.51. Suppose the angle is 162, then the velocity of E with respect to O is 2.07 meter per second. So in this way, we can find out the velocity of this slider, velocity of the slider E with respect to O, or fixed point, at various position of this crank. So let us see this animation once again in action. And you can see the value of this velocity is changing continuously over.